Hey everybody, we need to talk about chemical equations and the law of conservation of mass. I'm going to quickly go through these guided notes here in this video. Feel free to pause it at any point to write down what you see. Yeah, let's get to it. Make sure you have this paper in front of you. If you need it, ask me, I'll get it for you. So the first thing we need to write down is the definition of the law of conservation of mass. I know my handwriting isn't always the best, so I'll read this in case you can't read what it says. It says, matter cannot be created or destroyed. The atoms that go into a reaction must come out. So basically, you can't just snap your fingers and make atoms go away. You can't snap your fingers and make atoms disappear. You might rearrange the atoms before and after, so you might have different molecules going in and coming out, but the atoms that go in have to be there, even if they're rearranged into different molecules. All right, next up, I'm just going to uncover the rest of it here. Simple recipe for cake. Now, if you've ever baked a cake, you know that this recipe is going to be absolute garbage. This isn't going to taste very good, but the important piece here is that we're looking at the format of how we would write a chemical equation. So I want you to write this down, and I want you to write it in the same format I have. Flour plus sugar plus eggs with an arrow going to, oops, that's a C, cake. Sloppy, but you can read it. Flour plus sugar plus eggs becomes cake. Now, if you've seen an equation in your math class, you're probably used to seeing an equal sign here instead of an arrow. There's a couple reasons for an arrow being here in a chemical equation. For one, a cake is not the same as flour and sugar and eggs. If it was your birthday and I gave you a plate full of flour and sugar and eggs instead of a birthday cake, you probably wouldn't be very happy, right? Because flour and sugar and eggs is not equal to a cake. Also, it's an arrow going this direction because you can't take a cake and take it apart to get these things out of it. So the arrow cannot go this way. It must go this way. These things can become this. This cannot become these things. There may be equations that you'll see in the future, not in my class, but in future science classes where the arrow does go both ways. But in our case, we're always just going to see arrows that go to the right like this. All right, and a little bit of vocabulary here. These things we call reactants. And anything on this side of the arrow we call our products. Products. Hard to write and talk at the same time. In this case, there's only one product and multiple reactants. Doesn't always have to be that way, but. The other thing is that this arrow here is called the yield arrow. So it's not just any arrow, it's a yield arrow. I don't know, it's just an arrow, that's just what we call it. A sentence that I like to give to students to help remember which one's which is reactants react to produce products. So the reason I find that helpful, or that some students find that helpful, is because maybe the word reactant and product is a little bit scary, but maybe you know what it means to react and you know what it means to produce something. And so, I don't know, putting it together this way is maybe helpful. Also, it helps you remember that reactants come at the beginning and products are what you end up with at the end of the deal. All right, so this is a great example to sort of understand the general format of a chemical equation, but we need to talk about a chemical equation with like actual chemical formulas in it. I'm going to fold this just because I'm running out of space on my desk here. So we're going to talk about a candle reaction. So let's start by, it's helpful if you have a couple of colors. I'm going to use black, blue, and red, and I'm going to make a little key for myself here. In a candle, when a candle burns, there's three elements that are involved: carbon, hydrogen, and oxygen. So I'm going to use black to represent carbon. I'm going to use a black circle to represent an atom of carbon. I'm going to use this blue circle to represent an atom of hydrogen, and a red circle to represent my atoms of oxygen. Okay, so make yourself a little key with a couple colors if you can. Next up, let's write down the chemical chemical equations that are involved here. So I'm gonna write them big and all the way across the top so that I've got space to work here. So I've got CH4 plus O2 with an arrow, CO2 plus H2O. So notice I've written all the way across here. I've written it nice and big. I've given myself space between everything to work, which is important because we're going to need to write some stuff in there. If you've already written it and you didn't leave yourself that space, you'll be all right. Do make sure everything is capital. All of these elements are represented by capital letters, so that's important. One other thing I should mention here, CH4 isn't actually what's burning when you're burning a candle. When you're burning a candle, it's usually paraffin wax, which is like C52H47 or something. That may not be exactly right, but it's a really big molecule. CH4 is much smaller and just easier numbers. So that's what we're using. This is actually, if you have the stove that when you turn the knob, it goes tick, 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 and then a little flame pops up. That's what this actually is. It's methane gas. So anyway, same thing, just simpler. So our job now, this is our chemical equation. Our job now is to determine whether it is balanced, and if it's not, to fix it. So what we need to do is look at what happens before the reaction and after the reaction and see if it obeys the law of conservation of mass. So I like to do that for starters by drawing a line here to separate before the reaction and after the reaction. Remember, the arrow represents the reaction happening. So this is what you have before, this is what you have after. Next, let's draw each of these molecules. CH4 has 1 atom of carbon and 4 atoms of hydrogen in it. Remember, this is a molecule. If you remember, a molecule is anytime you have 2 or more atoms stuck together. So it's important that these are all touching because these are atoms stuck together into a molecule. O2 is going to be 2 oxygens stuck together, and I'm using red because I said oxygen was red. CO2 here is going to be 1 atom of carbon with 2 atoms of oxygen, 1 on each side. And then H2O is going to be 1 atom of oxygen with 2 hydrogens attached to it. Kind of looks like Mickey Mouse, so that's why I draw it like that. It's in that sort of V shape. Great. So this is what our chemical equation says now. I have a CH4 plus an O2 becoming a CO2 and an H2O. Now, we need to determine, like I said, whether this is balanced. So we need to count up our different atoms before and after the reaction. So if we look, for instance, at our carbons, you can see since I'm using black to represent carbon, I have 1 carbon over here in the reactants, and I have 1 carbon in the products. That's good, that's balanced, that's what we want. Let's look next at our hydrogens. Over here I have 4 hydrogens in my reactants and only 2 in my products. So those aren't balanced. We're going to have to fix that. Also, it looks like our oxygens aren't balanced. I have 2 oxygens over here and I have 3 oxygens over here. That's not balanced. So how can we fix this? Well, you can only fix it by adding more of what you've already got. Now we've only got 4 things here. We've only got CH4, O2, CO2, and H2O. Those are the only 4 things we could possibly add. So if we start by looking at our hydrogens, I notice that there's 4 hydrogens over here and only 2 hydrogens over here. So what I can do is I can add another molecule of H2O. So again, like I said, we can only add more of what we've already got. I can't just add 2 hydrogens. I have to add those hydrogens attached within that molecule of H2O. So I want you to draw another water molecule like that, and let's recount what we have. Well, I didn't change my carbons. I've still got 1 of those on each side. Now I have 4 hydrogens over here, and I have 4 hydrogens over here, so we fixed that. Now let's look at our oxygens. Here I have 2 oxygens, and over here I have 1, 2, 3, 4 oxygens all together, so I got to fix that. This is an easy fix. Since I have 4 over here and only 2 here, I can just double this one, right? And now this becomes like that. And now if we count everything up, everything is balanced out. I've got 1 carbon, 4 hydrogens, 4 hydrogens, 4 oxygens, 4 oxygens. Boom, we're all balanced out. Now, the final thing that we need to do, we've balanced out the picture, but we need to balance out the equation itself, the written equation. So if you think back to this cake recipe I told you, if I asked you to bake me a cake and I just said mix together flour, sugar, and eggs and you'll get a cake, for one, like I said, that would be a really gross cake, but also I didn't tell you how much sugar, or how much flour, or how much sugar, or how many eggs to use. That's an important part of a recipe, is how many cups of flour do you need and stuff like that, right? So in the chemical equation, we need to do the same thing. We need to specify how many of each of those molecules do we have. Well, here we just have one molecule of CH4, which means we're just going to leave that alone. Just listing CH4 there means put one of them. Now here we have two molecules of O2. So what I'm going to do is I'm going to go up here in front of the O2 and I'm going to put a big number 2. That says I need 2 molecules of O2. So when I draw that out, I know I can do one molecule of O2 and a second molecule of O2. Here I just had one CO2, so again I'm going to leave that the same. And then over here, since I had 2 molecules of H2O, boom, I'll put a big 2 there. Now the final thing on this notes page is a little bit of vocab, and that's down here. So first of all, this word is coefficient. Coefficient tells how many of a certain molecule are involved in a chemical reaction. So for instance, those are the numbers we just filled in, saying that I need 2 molecules of O2 here, and I need 2 molecules of H2O. So write that down, and then I want you to circle the coefficients in this chemical equation, which would be that big 2 and that big 2. Go ahead and circle those. Next, we've got subscript. Now this tells how many of an element is in a molecule. For instance, up here, I knew that there was only 1 carbon because it didn't have a subscript, and I knew that there were 4 hydrogens because it had that 4 subscript. So that subscript, sub means below, script means writing, so it's the writing below. So circle your subscripts, and that's the end of your notes. Now don't forget there is a back side to this paper, so you can move on to that next.